I'm talking today about the Exhibition Object Data Exchange Model, EODEM, which is a project organised by the CIDOC Documentation Standards Working Group. Today I want to give you a brief reminder of what we're doing, quickly look at how we got here, and I will examine the data model in some detail, looking at its extent, its organisation, how we use terminologies, and a few other general points. And we will review the next steps in EODEM's development. Our aim is very simple: to make it possible to export object exhibition data from a lender's collections management system at the touch of a button, and to import that data into a borrower's system produced by a different software vendor just as easily. Now, it should work like this. We start with an object which has been recorded in a database. The lender will open their collections management system and find the record, and they will press the export button and an EODEM file will be created. The lender will then email the EODEM file to the borrower. The borrower will receive the email and save the file. They will open their collections management system and press the import button, and the data will be stored in the borrower's database. So why are we working on this? Well, a huge amount of time is spent copying and pasting, or worse, retyping, object information between collections management systems and forms or emails. In the National Gallery in London, where I work, our best estimate is that over the 10 years to 2019, staff have entered an average of 405 loan object records per year into our collections management system. We happen to use TMS. Now, assuming 10 to 15 minutes per entry, this equates to between 16 and 22 days a year entering exhibition object data into TMS, and that comes to a total over the 10 years of between 164 and 224 days. So that's potentially an entire working year over those 10 years spent on data entry. And this ignores the work we do providing information for loans out. Now, the gallery has an ambitious exhibitions programme and we lend generously, but we are not atypical of large museums. Plus, there's the question of interoperability. Collections Trust currently lists 19 Spectrum partners on its website. The CIDOC Encyclopedia of Museum Practice lists 80 different collections management systems, and that list is very Eurocentric. It doesn't include many systems from Latin America, from Oceania, Australasia, or Asia. And each of these systems has its own data structure. They don't speak to each other. Now, the smooth transfer of object data between museum databases has been the holy grail of museum documentation since at least 1990, when the Consortium for Computer Interchange of Museum Information, or CIMI, was founded. There have been recent positive developments in this area, for example in the UK, where Art UK's successful data harvesting pilot project aggregated information from different systems. The Collections Trust have had various initiatives in this area, and the UKRI has a massive funding stream under the umbrella towards a national collection. But these initiatives all focus on exporting data for presentation and research. They don't tackle the fundamental aim of making collections management systems work with each other. EODEM's aims present a problem that is small enough to be solvable without too much effort. The project itself has evolved during a series of CIDOC conferences. It began with a discussion between Rupert Shepherd, Jonathan Whitson-Cloud and Norbert Kanter of ZCOM at the CIDOC Away Day during the 2016 ICOM Triennial in Milan. In Tbilisi in 2017, the CIDOC Documentation Standards Working Group held a workshop with documentalists to identify the units of information that would be needed for an exchange of exhibition data. And the following year, 2018, in Heraklion, at a roundtable discussion with various software vendors, we agreed that the project was doable and produced the first draft of the EODEM data profile. The project stalled in 2019, and then, as we reconvened in early 2020, COVID hit, so we have been working as a small group meeting online, including at the 2020 CIDOC conference, where we held another workshop for system developers, discussing some of the potential problems or questions that might arise during the development process. Our regular meetings include representatives from the DSWG and several software vendors. Now, those on the slide are participating in the discussions. Not all of them are implementing EODEM just yet. Other developers also receive notes from meetings. Over the last year, we've been focusing on the creation of a final data profile comprising a final list of units of information, an agreed data standard with which to encode the data and a file format in which to transfer it, and documentation to support the integration of the standard within software systems. And we've already identified several problems which, as a real-world system, EODEM needs to address, and which I'll be talking about today. For our data standard, we've settled upon CIDOC Standard for Lightweight Information Describing Objects, or LIDO, but we're using the new version 1.1 released in December 2021. EODEM's needs have actually informed some of the changes introduced in the new version, but this does mean that if a collections management system can already export or import LIDO data, it's already very close to being able to handle EODEM data too. And the decision to use LIDO also chose our file format for us. LIDO is serialized as XML. Now, some of our initial requirements contradicted the LIDO standard as it was when we were starting to draw up our profile. Luckily, LIDO was in the process of being revised. The draft of version 1.1 was issued for comment in April 2020 before being formally released in December 2021. We're particularly grateful to Regina Stein, chair of the LIDO working group, who's been working closely with us. This does mean that an EODEM record relies upon aspects of LIDO that can only be found in version 1.1. Our problems lay in three different areas. As originally defined, measurements in LIDO were measurements of the actual object, length, weight, height, etc. But we wanted to record measurements that relate to the object's requirements, and the LIDO working group agreed to extend the definition of measurements in version 1.1 to include requirements. We also wanted to tie these requirements to generic events such as display, transport, and so on. But events described in LIDO must be specific historical occurrences. However, the LIDO working group advised us that our events could be considered as historical occurrences if we conceive of them as being the assessment that took place to determine what an object's display requirements should be. We also needed a way of identifying a group of sets of measurements which are all about one thing, for example, an object's temperature requirements. And the LIDO working group assigned a new attribute to the unit of information that contains individual measurement fields to accommodate this. And finally, the LIDO working group added new terms to the LIDO Terminology Authority to support our needs. After much discussion, we've settled upon a set of units of information which we feel are useful without being too extensive. There are currently 109 of them, and this is where I add, in large friendly letters, the words "don't panic." Let's look at those units of information in more detail. First of all, 33 of them are wrapper units, which contain no actual data, but only descendant units. These are imposed upon us by the LIDO data structure. Another 14 units are made up of keyword identifier pairs, and for 6 of those pairs, we only require the keyword element if it is included in the record. Another 1 unit is effectively duplicated because of the way we're implementing LIDO, which leaves us with 69 units of information. Even at this point, I doubt that any collections management system has fields for every one of these units, never mind a museum having data in all of these fields. Again, though, I'll say, don't panic. Because of these units of information, only 13 are mandatory. If we focus on those mandatory fields, it's important to know that we expect that 7 of those fields will be filled in either with system values or standard values that are applied to every record upon export. The key point is that EODEM works on the principle that anything is better than nothing, and so the only mandatory units of information for an EODEM record where we expect values to be held as dynamic data within the collections management system are object type, title or name, title type, which in many systems may also be a default value that's filled in on export, title language, again quite possibly a default value, an object identifier, and the type of record, whether it represents a single object or a group, which is mapped to a specific set of identifier keyword pairs on export. If a system can export or import these 7 fields, then it is EODEM compliant. And if a museum can provide 4 pieces of information, object type, title or name, object ID, and record type, then it can provide a valid EODEM record. Now, obviously, we hope that museums are able to provide more data and that collections management systems will be able to export or import into more fields, but this is all that's required for a valid EODEM record. Now, I'd like to talk a bit more about some of the principles we followed when drawing up EODEM. One of these relates to data granularity. For example, a set of dimensions, say for a painting, which has a height and a width, 176.5 by 191 centimeters. This can be expressed simply as a string of characters, or it can be broken down into individual fields, a type, a value, and a unit, one set each for height and for width. But what if a collections management system doesn't have those granular fields? Now, EODEM won't force the addition of new fields on systems. It will accept an unstructured string. Now, in reality, dimensions are usually broken down into individual fields, but it's quite possible that entering data like this proved too time-consuming, or perhaps users have only been able to cut and paste a string from an older system. And what about names for people? Or temperature requirements? The key thing is that many EODEM units of information include both a free text field and a set of structured fields, and the source system will deliver whatever it can. And the developers of the receiving system will decide whether they want to try to parse unstructured strings into separate fields or take them as is, or indeed whether they want to take structured data and concatenate it into strings. Everything will depend on the vendor's individual systems and how much work they want to put into EODEM. Now, let's take a closer look at how EODEM records are arranged. An EODEM document follows the basic structure of a LIDO document. It contains a wrapper for the document, a wrapper for each object, within each object a wrapper for object metadata and for record metadata, and then within the object metadata, blocks of data that are dedicated to the object's classification, the object's identification and description, and relate events relating to the object, starting with its production. So far, so good. But how do we accommodate objects' requirements, the security, shipping, and environmental standards, and so on, required to keep the object safe during the loan? Now, these are conceived of as relating to one of 3 kinds of event. First is a loan assessment that encompasses the object's value, its insurance and indemnity requirements, and its current condition. Next is an assessment of the object's move requirements, so that covers handling, transport, condition checking, and hazards. And finally, the object's display requirements, which covers its requirements for temperature, relative humidity, visible light exposure, and ultraviolet light exposure. Also methods for installation and display, security requirements, and requirements for photography and filming. Now, some of these requirements could equally have been described as related to movement or to display, and we don't want to record them twice, so we basically took a decision as to which group, which event they should each be recorded in. Now, individual requirements fall into 2 kinds. Blocks of narrative text and numerical data. Textual requirements are formatted as what LIDO calls descriptive notes within these events, and the content of the individual note is identified by the description's type attribute. Numerical data requirements are tagged as sets of measurements within these events, and there are 2 attributes in the containing element which specify: 1, that the measurements are of the object's requirements, not the object itself. That's the type attribute. And another, that the block of measurements being described, what it actually relates to, in this case, temperature requirements. And these are in the measurements group attribute. The precise type of measurement, in this case a minimum temperature, is specified in the measurement type block here, and the unit, which is usually predefined in EODEM, is in measurement unit, and the actual data, the value itself, is in measurement value. Obviously, lenders and borrowers will want to incorporate EODEM into their exhibition management workflows, and in practice, this means that object data will probably be updated in 3 stages. First, when borrowers send out an initial informal inquiry about the possibility of a loan. Then, when a loan has actually been agreed and the lender has stipulated their conditions. And finally, when all preparation for the loan has been completed, the object's measurements have been updated and its requirements finalized following conservation, etc. So data for the same object needs to be imported several times, and the importing system has to decide each time whether to append a new record or update an existing one, and to make sure that it updates the correct object's data if that is what it decides to do. Now, the export date timestamp unit of information will be crucial here, and it must contain an ISO 8601 formatted date and time with a time zone value. There are some further general principles which developers will need to bear in mind. If we consider export, then a key one is that no unit of information can be repurposed. It either contains the defined information or should not be used. If EODEM calls for a single value, but the system contains multiple values for the same unit of information, then don't concatenate values. Export either whichever value is defined in the system as preferred, or failing that, just export the first to be listed. There are several units of information in EODEM which may not exist in a collections management system, but where it may be able to add default values upon export. And of course, these might be fields which it would be worth adding to the next version of the exporting system. Then, if we look at import, clients may want to overwrite some supplied values. For example, title type might always become lender's title on import, regardless of what has been supplied. An EODEM record may also contain units of information for which there is no place in the borrower's system, and vendors might want to find a way of munging any unmappable units into some kind of dump field. EODEM actually has very few requirements for standardizing the terminology used in actual data. When it does, these are mostly intended to make sure that data values are properly interoperable, that is, that they can be interpreted by other systems. We've tried to use either existing international standards or accepted web standards. In these cases, we expect that developers will convert local values to the standard upon export and, if necessary, convert them back to their system's local values upon import. These conversions will probably be applied generically on export or import rather than change according to individual data values. However, EODEM does make extensive use of linked data identifiers within framing data in order to identify which particular unit of information is being described. In nearly all cases, it should be possible to hard code these into the exporter or importer. Now, we needed these in 4 areas and are very grateful to the 3 organizations who have very quickly added our proposed terms to their vocabularies. There's the Getty Vocabulary Program, who have added terminology regarding environmental requirements to the Art and Architecture Thesaurus. There's the LIDO Working Group, who have added event and measurement types to LIDO terminology. And there's Collections Trust, who have added some new collection management concepts to Spectrum as candidate terms. Now, these terms all take the form of linked data identifiers, and the use of linked data identifiers is also related to a potential problem, how to align vocabularies. This is particularly important for makers' names, because nobody wants to keep adding duplicate records for the same person into their database. So developers will probably want to include some mechanism for mapping imported terms to those already in the system. Now, hopefully they can reuse their existing tools for bulk imports, which may have that kind of functionality already built in. But this is where the adoption of the LIDO data structure will be an advantage. Much of the LIDO model is based around combinations of text strings in blue on the slide and identifiers in red. If the identifiers use standard vocabularies, then an importing system could use these identifiers rather than the actual string to match the term in question. Now, object records may be exchanged in more than one language at the same time. It is not the exporter's job to anticipate which language an importer may prefer. They should export records in whichever language is or languages are available in their system. But a record's language must be explicitly labeled using record language, which is the XML language attribute of the descriptive metadata element. Different languages must not be assigned to individual elements within descriptive metadata. A separate descriptive metadata block should be exported for every language used. The only exception to this is for titles and names, where multiple titles may exist in different languages within a single descriptive metadata block. However, the individual languages must be specified using title language. Now, this means that importing systems must decide either to accept records in all the languages offered, or to define a hierarchy of preferred languages from which the highest will be imported, failing that the next highest, and so on. Ideally, images will be shared using URIs pointing to openly accessible images on the web, whose address is contained in the image unit of information, which is the LIDO link reference element. If this is not the case, an image should be provided as a file alongside the EODEM XML file, with only its file name defined in the image field. This means that the package of data within an EODEM transfer will comprise a single XML file, meeting the standard for the EODEM profile of LIDO 1.1, and 0 or more image files. EODEM importers will expect to find a folder containing these files and nothing else. Now, how the file is transferred between lender and borrower is up to them. EODEM has no preferences. Equally, files may be processed in some way, for example, zipped and unzipped as part of the transfer, or they may not. But an EODEM compliant importer will expect its source to consist of a single unzipped folder containing an EODEM file and 0 or more image files and no subfolders. Finally, there's the question of security. An EODEM file may contain sensitive information about one or more museum objects, valuations, security requirements, installation methods, etc. Now, at the moment, this information is routinely transferred between borrowers and lenders in relatively insecure formats, as unencrypted email messages or in unencrypted files attached to email messages. So, emailing EODEM files is no more or less secure than current common practice. If lenders are concerned about the security of their data, then they might consider wrapping the EODEM files in a password-protected zip archive before transfer and sending the password to the borrower using a different channel from the one used to send the data. But remember, EODEM importers will not expect to deal with a zip archive. The files must be unpacked before running the importer. So where are we now? We spent the last months establishing EODEM as a formal profile of LIDO, and Richard Light has very kindly been doing the bulk of the work. EODEM will be the first formal LIDO profile to be implemented within an integrated technical framework, which takes the form of, first, a single XML document which contains a description of EODEM in the form of changes to the LIDO XML schema and human-readable documentation of the EODEM profile. And this single document can then be used to generate an XSD schema file to validate EODEM LIDO records, human-readable documentation in HTML and in PDF comprising a list of units of information and how to extract them from the EODEM document, and this will help developers to query documents for import. It also produces an HTML outline of an EODEM document structure, which helps developers construct documents for export. We also have a sample EODEM document with real-world examples, and we're developing an XSLT file embodying a set of schematron rules to provide richer validation and more useful failure messages. We think that these are far enough developed and sufficiently mature for us to be able to announce today that the current release of the EODEM profile, version 0.08, is a public beta. Software developers now have access to an EODEM XML schema document, a human-readable LIDO profile, a sample record, and an online viewer to preview LIDO records. We can also demonstrate proof-of-concept importers and exporters for an EODEM record in Museum Plus and modes. And here I'd like to say a particular thank you to Jette Klein-Berning at ZCOM and Richard Light, formerly of the Modes Users Association, who've been doing the bulk of the heavy lifting when it comes to XML processing and demonstrators. Now we still need to finalize our schematron to work with the latest version of the profile and update sample tools and templates to show developers how to work with the raw XML file. So what's next? Well, the next stage is to test the beta profile by actually trying to develop importers and exporters. We hope as many system vendors as possible will do this, and so far we already have 9 software suppliers on board. All 9 are already either developing or planning to develop an EODEM exporter, and 4 are working on an importer too. Once we have reviewed and incorporated developers' initial feedback, we will be ready for a stable release of EODEM version 1, which we hope to be able to announce this autumn. The 2022 ICOM conference is probably too soon, but the UK's Collections Trust Conference or the European Registrars Conference might be suitable venues. So, what resources are available to help you develop EODEM? You can find links to all necessary files at the project's homepage on the CIDOC website. Relevant files are also available in the CIDOC file store. Just filter it by EODEM and look for the most recent files. And we have an online viewer which will enable you to preview EODEM files once they've been generated. If you're looking for support, we have a support email address which we hope will work like a basic forum. We also have a Slack workspace, currently quite quiet, but that's available if you like that kind of thing. And if you want to get really involved, you could join our monthly meetings. Just let me know. So I would like to say thank you for your attention.